Okay, today in chemistry we're going to talk about ionic bond formation, but before we do so, let's review valence electrons and electron dot structures or Lewis dot. Okay, valence electrons are, if you'll recall, the electrons found in the outermost energy level of an atom, and they determine the chemical properties of elements and the type of bond formed. You can determine the number of valence electrons by looking at the atom's electron configuration, or more simply, by looking at the group number for from the periodic table, and this works for your group A elements. So if you'll recall, 1A, they have 1 valence electron, 2A have 2 valence electron, 3A have 3 valence electron, 4 valence electron, 5, 6, 7, 8, with the exception of helium. Valence electrons are often shown in electron dot structures. So put this video on pause for a second and do me the electron dot structures for the following elements. Okay, so hopefully you said hydrogen. Hydrogen has 1 valence electron. Beryllium has 2. 1, 2. Remember, you're going to space them, put 4 before you pair up. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. And then argon has 8. 1, 2, 3, 4, 6, 7, 8. Sometimes people, where you have a pair of electrons, they will put a line like that represents 2 electrons, 2, 2, 2. Okay? All right, so let's talk about ionic compounds and ionic bonding. So an ionic compound is composed of cations and anions that are combined so that the number of positive and negative charges are equal, or they're equal to 0. So remember that we balanced charges when we wrote formulas. Metals and nonmetals typically combine to form ionic compounds. So your metals will give up electrons, they become your cations. Your nonmetals will accept the electrons, they become your anions. When you have an ionic compound, they do not form molecules, but instead they form aggregates or crystal lattices of positive and negative charged ions arranged in a pattern. And so lattice energy is defined as the energy released when 1 mole of an ionic crystalline compound is formed from its gaseous ions. And there's a chart on page 217, and then another something on page 213. The value for lattice energy is negative, simply meaning that energy was released. Okay, characteristics of ionic compounds, and this is compared to molecular. So ionic compounds tend to have higher melting points and boiling points than molecular compounds because ionic bonds are stronger. They're usually solid crystals at room temp, so there's an attraction between those positive and negatives. It holds them into a solid. Usually it occurs between metals and nonmetals. They're composed of cations and anions. Although they are composed of ions, ionic compounds are electrically neutral since the total positive charges equals the total negative charges. Okay, so ionic bonds. Ionic bonds occur because there's an attraction between the charges. It's an electrostatic attraction. And we can use electron dots. So let's draw sodium. Get a clean sheet of paper here. We're going to draw sodium and chlorine. And then we're going to do calcium and nitrogen. All right? So you can use electron configuration. So for instance, if we draw out sodium's electron configuration, you would say it is 1s2, 2s2, 2p6, 3s1. Okay? Chlorine's is 1s2, 2s2, 2p6, 3s2, 3p5. Okay, so if you'll recall, atoms want 8 electrons in their outer shell. This sodium has 1 electron in its outer shell. If we could remove this electron, its next shell in, the second energy level would have 8. Chlorine, on the other hand, has in its outer shell 2 plus 5 is 7. If it could pick up 1 more, then it would have 8 in its outer shell. So this electron from sodium will move over to chlorine and cause it to have 6 electrons in that p sublevel. So now sodium has 8 in its next shell in, and chlorine's outer shell is full. Well, you can do that, but that takes a little bit more time, so we're just going to do Lewis dots. So we have sodium. We know it has 1 valence electron because it's 1A. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. So this electron from sodium is transferred, so always use an arrow, transfer it over, and then I always put it as an X so I can remember that I transferred 1. Now, this sodium lost an electron, so it develops a positive charge. This chlorine picked up 1 more electron, so it is a negative. Your positive and negatives are equal, and so your formula would be 1Na to 1Cl. Okay, let's try this one. Calcium, and I'm just going to do it with Lewis dot. Calcium has 2 valence electrons. Nitrogen has 5. 1, 2, 3, 4, 5. Nitrogen needs 3 more, so this calcium is going to transfer this electron here and this electron here. This calcium now has lost 2, so it's a 2+. Well, the problem is nitrogen still needs 1 more, so we're going to bring in another calcium. We're going to transfer this electron here. So now nitrogen has picked up 3 electrons. It has a 3-. Well, we have a calcium that still needs someplace for this electron to go. So here's another nitrogen. 1, 2, 3, 4, 5. This electron transfers. This calcium now has lost 2. Okay? Nitrogen still needs 2, and our charges are not balanced, so we're going to bring in another calcium. The electron is going to be transferred here. Electron is going to be transferred here. This nitrogen has now picked up 3, so it's a 3-. This calcium has lost 2. It's a 2+. Now check your charges. 6-, 2, 4, 6, 6+. So we are balanced. So your formula is Ca3, because we have 3 calciums, N2. So this is what we were doing in the last chapter just by crisscrossing. Okay, so that is it for ionic compounds. So you are now going to do set 2.